So we are going to continue looking at our exponential functions. Tonight we are going to be looking at modeling using exponential functions. So let's compare exponential and linear models. So given the following two data sets, we see that the intercepts for both of these are the same. The growth at the beginning is a little similar, but as we get farther and farther away from that initial value, we see that these functions take on very different shapes, very different values. So let's consider what happens first with the f of x function. And so to go from 2 to 5, I'm going to go plus 3. And to go from 5 to 8, plus 3. To go from 8 to 11, plus 3. And to go from 11 to 14, I have gone plus 3. If we were to look at a graph of this purple function, f of x, it would look something like this. The fact that you are adding 3 each time shows that f of x is a linear function. We've seen this in analyzing linear functions at other times in this class. When we look at g of x, to go from 2 to 6, we're going to be multiplying by 3. And 6 times 3 is 18. And 18 times 3 is 54. And 54 times 3 is 162. So where a linear function adds 3 for consecutive x values, that is the idea of the slope. When we look at an exponential function, we are instead multiplying by 3, and we see that that is the idea of having a base of 3. If we use the process that we talked about earlier in this video to determine the exponential function that we get here, we will see that the exponential function for g of x is going to be g of x equals 2 times 3 to the x. If we use information learned earlier in the course to calculate the linear function for f of x, we see that f of x is 3x plus 2. Going ahead and putting that g of x function on this same graph, we see that our g of x takes a different type of shape. It is not a linear graph, it is that exponential curve that we talked about earlier. So let's look at a regression example using exponential data. Here we have a 2007 university study was published investigating the crash risk of alcohol-impaired driving. Data from 2,871 crashes were used to measure the association of a person's blood alcohol content with the risk of being in an accident. The table below shows the results from the study. The relative risk is a measure of how many times more likely a person is to crash. So, for example, a person with a blood alcohol content of 0.09 is 3.54 times as likely to crash as a person who has not been drinking alcohol. At this point, pause the video and input the data. Use the BAC data that you have listed there as your x value listed in L1, and list the relative risk of crashing data as your 2. As your L2. So we put that data in the calculator. And if you have not finished putting the data in the calculator, just pause the video, rewind for a second, get the data. You can either take it from here. There's all the data except for the one point at the end. So there's your data. Or you can just backtrack a little bit and get the data off of the information that was on the screen earlier. But now that we have it, we're going to look at a scatter plot of this data. So I'm going to hit second, stat plot. Make sure that my stat plot is on. If it's not, I go there, I turn it on, and then I'm going to hit zoom 9. And that is my zoom stat command, and I see that this function looks extremely exponential. So now I'm going to hit stat again. This time I'm going to go over and calc. And this is just like we did regression with our cubics and our quartics and our lines. But now if we arrow down to 0, we see EXPREG. That's exponential regression. So I'm going to hit enter there. List 1, list 2. I'm going to store my regression in my Y1. Oops. You might have it look like that. So I'm going to go comma Y1 and enter. That's made a regression equation. Notice it is a times b to the x. We are used to seeing that in the form that I gave it to you on the notes. It was c times a to the x, but in this case a is our constant, b is going to be our base. So we have an r squared value of 0.97, an r value of 0.98. So this is extremely strong exponential regression. Since I put it in the y equals, if I zoom 9 now, I see that there's my data and my model is very, very true to that data set. Now, if you look back a couple of the questions that it asked us, if X is the BAC, we did the model, and now you can see, how alcohol affects drunk driving. So that's how you do an exponential regression. It's just like doing the other types of regression that we've done. So there's that.